The first module we're going to take a look at is the parts module. This is where you create the 3D geometry of the part. Now, if you've worked with CAD softwares in the past, such as CATIA or SolidWorks, you have a general idea of how you create a part in CAD. In some ways, Abaqus is similar to other softwares, but it also has other differences. Because when you're creating a part here, you also have to specify what kind of analysis you're really going to be doing on it. So we'll go ahead and double click on parts, and there you see the create part window. We're going to name our part barbell stand. In the modeling space, we're going to choose 3D because this is a three-dimensional object that we're modeling. If you were maybe doing a two-dimensional analysis where you've only got an X and Y axes, you don't have depth, this could be with maybe a sort of planar shell analysis, or maybe you're just modeling a 2D truss, or you could in fact be modeling our barbell stand but only from a 2D perspective. In that case, you'd go with 2D planar, but we're going to go with 3D. In the type, we're going to choose deformable because our barbell is essentially a deformable body. Now, it's going to be a very strong body because it's made of steel, but even steel is deformable, so we want to specify that in the type. The third category here is the base feature. You've got solids, shells, wires, and points, and we're going to go with solid. You might go with shell if maybe you're modeling the exterior fuselage of an airplane, which is basically the tube in which people sit in an airplane. And you might go with wire if you're doing a truss analysis and you're modeling each of the elements of the truss as wires and using truss elements along them. But we'll get into that stuff later. For this simulation, or this tutorial, let's go with solid. And the type we're going to choose is extrusion. You've probably heard that word before if you've dealt with any CAD softwares. An extrusion is where you create a sort of sketch and then add depth to it to create a three-dimensional object. You could have gone with revolution or sweep. A revolution would be useful if maybe you were creating a body like a disc. But in our case, we're going to go with extrusion, and you'll see how it's done in the next step. The approximate size essentially tells Abaqus, or rather gives it a general idea of how big your object's going to be, how big your part is going to be. So it initially sets you up on a graph paper that's about the right size so that you don't have to zoom in or zoom out too far. So this is not too important, it's more of a user convenience feature. So I'm going to say 5, because our barbell is about 1.5 meters high. So I want to be in that same order of magnitude. And I'm going to click continue. What you see now is the sketcher window. This is a 2D sketcher interface, and I can use the scroll wheel on my mouse to zoom in and out. So I'm zooming out right now, and you see it's given me a 5x5 graph paper just because I set 5 as my approximate size in the create part window just a moment ago. I'm going to zoom back in on this, and we're going to start modeling our barbell. Now, one thing I should point out, when we double clicked on parts, got the create part window and then hit continue, and it brought us into this interface, it also changed this toolbar you see on the left over here. You see, depending on which module you are, this toolbar changes accordingly, giving you the tools you need in that module. And also up here, Abaqus tells you what module you're in. Although you could just look at your tree over here and it basically reflects the same information. We're not going to look at each and every one of these tools in this video. In fact, we may not look at all of them in the entire set of tutorials. Some of them you can probably figure out just by clicking on them, playing around with them, and if you have experience with CAD, you'll pick this up pretty quickly. So we're only going to use the ones we need for the simulation, and hopefully that'll get you started. So the first one I'm going to click is the Create Lines Connected tool. I click on that, and I'm going to start out at the origin, and I'm going to draw up a basic sketch, kind of rough without dimensioning at first, outline of my barbell stand. You see, I just keep clicking and moving around. Like that. And when I do the last click, Abaqus sort of detects that I'm closing in on myself, and it helps me complete the loop to create a closed sketch. Because remember, you always need a closed sketch in order to do an extrusion. Next, we're going to apply some constraints to this. Well, you'll notice Abaqus has already gone ahead and put in some constraints. See, H stands for horizontal and V for vertical. And Abaqus sort of detected that when we were drawing, that, hey, you're trying to create a vertical line, so I'm just going to go ahead and put a V next to it and apply that constraint for you. But there's others that Abaqus doesn't pick up on its own. For example, we want this vertical segment to be the same length as this one. So what I'm going to do is go to the Constraints tool, and I'm going to click on Add Constraint. Now, the constraint we want is the equal length constraint, so I click on that. And Abaqus tells me down here, select the lines for the equal length constraint. So I come over and I click on the first segment, then I hold down the Shift key on my keyboard, and I click on the second segment. And you see both of them have been lighted up in red as I did that. You gotta hold down the Shift key when you're selecting more than one segment. And then I come over here and click Done. And now you see Abaqus has added that tiny little line there that sort of tells me these are equal length. So I don't want to add any more constraints right now. I'm just going to go ahead and close this Add Constraints window. And the next tool we're going to use is the Add Dimension tool, which is over here. I click on that. Abaqus tells me to select the entity to dimension. So I guess we can start by dimensioning the overall height of the barbell stand. So we want to measure from up here to down here. So I'm going to click on that. And Abaqus's initial reaction is to assume I'm trying to measure the horizontal length of the segment. But if I start moving upwards like this, and I move my mouse over the second segment, it realizes I'm trying to actually find the distance between those two segments. I click again, I drag it out, and click a third time. Now at the bottom of my screen, I can enter in the actual dimension itself. So we're going to go with 1.5. Now you see our dimensions were kind of off. Like my sketch was not very accurate at all. And it seems to have made a little bit of a mess over here. And maybe I should have started out with dimensioning some of the other parts first. So I'm going to backtrack just a little bit by undoing my previous option. You can do this by going to the Edit menu and choosing Undo, or you could hit Ctrl-Z on your keyboard. I'm going to undo this so we are back to where we were a step ago. I'm going to come back to the Add Dimension tool, and this time I'm going to dimension the thickness of this protrusion. and I click on the first one and then the second, pull it out, click again, and I'm going to set this to 0.1. I'm going to go ahead and dimension the rest of this object. Notice when I change this segment to 0.1, it also changed this segment over here because we've constrained them to be of equal length. So we've got our sketch dimensioned out exactly as it is in the schematic. It looks kind of small over here, so what we can do is go up here and click on the Auto Fit View button. And when I click that, it sort of fits it to my screen so you can see it a little bit better. And now that we're done dimensioning everything, we're gonna hit the red cross over here to cancel the procedure. And where it says sketch the sections for the solid extrusion, well, we've completed sketching it. So we're going to click on done. This brings us to the edit base extrusion window. Now we've created the base itself, which is the sketch. And now Abaqus is asking us what depth to give the sketch in order to create the three-dimensional object. So I'm going to tell it to go with 0.1 again, as per our schematic, and I will click OK. And there you see Abaqus has drawn out our part file, or our part.